Okay, thank you very much, Stefan, for the introduction. Hello, everyone. Our focus is how OPC UA is used in European railway infrastructure. And as Stefan said, I'm today presenting together with Wolfgang Klein from German Railways, from the infrastructure part, and he will, in the second part of this presentation, report on the usage, where it is used in operations. So, before I begin, I would like to briefly introduce myself. I work for a company called praedicta, where we are modeling the railway systems. I will show that later on. And so this is not only thin air, we are also doing reference implementations to really know that the standards we are producing are really working in practice. In addition, I hold a chair of distributed systems here at the University of Applied Science in Mainz. And in the context of Europe's rail, I serve as a lead author for standards on diagnostics and configuration. And if you have any questions after the session, feel free to reach out to me via email. So this is an example, and I will start with the information models, because that was the most important thing that brought us to use OPC UA. And here there is an example for a logical model. So we are creating product group models for each subsystem. This is a point. Everyone knows it's turning left, it's turning right, so that you can choose where you go to. And we are also producing such models for signals, for level crossings, for interlockings. And these models are there from the operational perspective. Can we produce? So is a point turning left, turning right? That is the question we would like to answer. And on the right side, not sure if you can read it, we have a generates event for a point turn event. So we are collecting the data from a point while it is turning from left to right. And we are measuring the power during that time. That's approximately 4 to 5 seconds. And we record this in motor turn data. And we can then compare how a turn is now, how much power do you use during the phases now, or how much power you will need probably in a year from now. And from that on, you can do your model on maintenance planning. Is the end position reached? Is another example. Do you running into a timeout? So this idea is very universal. So it's also useful probably for barriers going up and down on level crossings. You want to know how much power you're using there, or if you have a vehicle, you could also see doors closing and opening would be very similar to that. The basic idea is for these kind of models is they are all the same for all manufacturers. We allow in those models also manufacturer-specific extensions. So if you have additional attributes, you can add them to this as a basic model. As an operator, and this is where I work for, so the operator needs to understand the data without any magic numbers, which are traditionally a lot in the data you're getting there. So understanding the data is key, and this enables a consistent data mapping across all the manufacturer and deployments we are having. And this is key for any scalable condition monitoring and predictive maintenance if you want to do it on a network level. So on the next slide, we see that we are not only producing such models for the infrastructure looking on itself. That would be the on the right side, on the lower right side, the infrastructure monitors itself, but the infrastructure could also monitor the vehicles traveling along there, which would be called a checkpoint. So you could measure wheel forces, loading parameters, camera bridges for graffiti, hot box detections, or hot brake detections, and so on. So there are lots of different modular checkpoints and vehicle monitors infrastructure. This would be something like you're traveling on a regular train, and this train would then measure, for example, the longitudinal height. So if you have any bumps in the, and you would really see the difference from day to day, and that you're monitoring such data. That is very useful. And the same would be for vehicle monitors itself. That would be the same as infrastructure, but just that you have in-vehicle monitoring of the systems. So on the next slide, you see another model we are using, and they are getting into context in the next slide. So this is a physical model. We call it the equipment model. Our operational user stories will bring the right spare part for the repair. That is key. In the past, we very often had the problem, you have to go there, you are checking what is wrong, and then go back, bring the spare part. So if you're just informed about the right part, bring it with you directly to the repair. If you have a safety relevant recall, you need something like batch traceability. So you have identify all installations affected. And the answer is the equipment model. So you are describing the standard building blocks, and we are having the materials, and the materials is a type of equipment, something you can order. And so if you have the standard building blocks that can also be used in a hierarchy, that allows each manufacturer to describe his system architecture in a standardized way. So it's not that we are standing the system architectures, it's just that we are describing how they are described so that we can read how the system architecture is built up. So equipment consists of equipment, we have the serial numbers, and from this on, we are building an online inventory that is very near to what we have as a catalog of spare parts, so that we really know, okay, if something is failing, what would be the material of it, and the serial number is being replaced, and the new serial number is coming in, so we can trace all the materials going through the process. On the next slide, we see the references, which is also a very important part in OPC UA. So, of course, we have the hierarchical references. As I said, with the equipment model, has component, so we have the breakup structure. But the references are really key to understanding the system if it comes to the functional, non-hierarchical references. For example, if you have an implements reference, we have the link from the logical model, the product group, which I presented the first, to the physical equipment model, that we know what is the correct replacement. Or something else, it provides power reference. If the power supply fails, which equipment is powered by it, may be affected, and repair the root cause. Don't repair anything that is not the root cause. Or we also have is part of redundancy group references. So if a failure is there on a lower part of the system, then that might not necessarily be a failure at a higher system level. That might be an error, but you're still having all your functions available. So you can understand the resilience and of the specific system architecture. This is very, very important in railway systems, because many people think from the outside it's quite easy, just drive the train. But for example, if you set a route, then 100 of product groups have to work with a logical end. And this is why you have to understand your system, and the non-functional, the non-hierarchical, the functional references are key in understanding the root causes in a manufacturer-independent way, and to do this on a system-wide level. So this is about how the standardization started. So we started at DB InfraGO. We created models for the digital interlockings for a lot of subsystems. I already mentioned them. It was called Neupro. And these standards then went to Europe's rail. And there we then are further going down in the standardization to have it at least at a European level. And why is this important? For manufacturers, you can then have a single product design that can be sold across Europe without costly adaptations for this and that railway. And from the infrastructure manager perspective, you can have high volume products, which then of course enable faster modernization and reduce the complexity of the complete installations. So that if you get it from one manufacturer, it's very similar to if you get it from another manufacturer. So we are also creating the service functions that are collecting the data. This is for the service function diagnostics. So if we have all those information models available then we need to aggregate all the data from all the different manufacturers, all the different installations into one namespace. And this is then serving via another interface, OPC UA interface. It's called Standard Diagnostics Interface DS. And there are many application-specific extensions in this service function diagnostics. And as you can see, we have here also a different role of the asset management system. You can see it on the higher system level. And normally, all the assets were known directly, or you put them into the asset management. And now, with this approach, you can read the asset inventory directly from the field via our equipment model I presented before. So you have the single source of truth in the field, and that is a really a big shift in what is happening in the railway system. Another service function is a service function configuration and service function loading. Loading is the one we are having today, and the service function configuration on the other side is the one we are developing as a standard. And this uses file transfer here, SMI version 2, to actually upload files for firmware or parameterizations to the field elements. And this also needed a specific interface which was only available in interlockings. And this is why we created a new service function configuration that has a repository where we have big dependency trees that this software version relies on another software version. And there is also a safety-related safe configuration authority. That's the one you're seeing here in red, and that you can do safety-related configurations throughout the railway systems. And this is being developed as a standard also on Europe's rail. And if you go through the different phases of this configuration, then we have the data preparation phase. We are doing the preloading that can do during operation. And then we have the deactivation of the incompatible safe building blocks. So you see in the dependency trees what the versions have been before and after. And the safe ones have to go out of operation, that you really have a clear point in time where you have your version switch, top-level release version switch. And then we go through the activation and the confirmation, which is quite important to have this also, to have a good lease policy here, and to really know if it's a safety-related part, that you have a safety attestation, that you have put the right building block configuration on the right system. So why is OPC UA ideally suited for our applications here in railway? So I think we already heard a lot about the information models. So standardize the semantics of data exchange was key. And this brought us to OPC UA. We also have the flexibility to have supplier extensions. That is also important. Also to build then upon these on the next level of the OPC UA information models. References are important, of course. As I said, historical data access is built in. You don't have to invent anything new. Subscriptions, you can change them at runtime. You can drill down into the data. Events, alarms, you can put together data and compare this data with data that you are having later on, and that is in a comparable structure that is very efficient for many use cases. We are having point-to-an-event was one example. Syntax is built in. You don't have to care about that as you would have in other, if you have a protocol-only stack. Then roles and permissions. So not everyone can activate the configuration. So this has to be done with roles and permission. We have method calls that we can use for that. And the SDKs are quite mature. And this really brought us to OPC UA. Now I will hand over to Wolfgang Klein from DB InfraGO, who will show us how these concepts are applied in the real-world implementations. Thank you for the time now.
Hello, thank you, Karl. My name is Wolfgang Klein. I'm from DB InfraGO, this infrastructure part of the German railway, and I'm responsible with my department for the diagnostic and operation systems for the interlocking. And yeah, 10 years ago, we started also with Karl with a diagnostic of our point machines. We operate a very big network, as you can see, with about 30,000 kilometers of railway network in Germany. I think in China and India it's bigger, but in Europe it's one of the biggest. And we operated about 4,500 stations, and we are responsible for the rolling. Our customers are the rolling stock companies which operate their railway over our network. Okay, next sheet, please. Okay. In 2014 or 15, nearly 10 years ago, we started with OPC UA at German Railways. We started with a pointing machine diagnostics. We have around 28,000 critical points in our network, and though every delay we see, or a lot of them, comes from this switching points. Therefore, for us, it's necessary to make a good prediction when it could be failed, and so we install so-called lockers on this locking machines, on this point machines. So what you can see in the interlocking center here, it's a sensor. You can see it's a Hall sensor. We developed it by ourselves, and it's clipped over this wires, which goes out to the point machine, and then the information, the current goes into a logging box. It's from Structon, and this logs the data completely, and this also acts as OPC UA server. And though it stores all the historical data, all the current curves sampled, digitally sampled, and from there we put this information in our diagnostic platform. It's called Diana. It's a big fat OPC UA client, and it makes the predictions when a switch may fail. And we can see it from the historical data. We can compare the curves. We see the prolongation of the switching time, or if the current goes up, we have an impression that the motor could have a problem, and therefore we were able to avoid around 5,000 switch point machine failures per year. So we detect them before the switch really falls down, and this is where we started. And I think it's still in operations, the system, and now 28,000 point machines around Germany are overviewed by the system. Okay, but there's one application. The other one is regarding the level crossings. In Germany, we have around 16,000 level crossings through the country. Not all of them are technically secured. So there's a smaller ones, not, but the biggest ones are technically secured. That means we have an electronic device which control the machines, and some of these are still relay controlled. This is the old technology from the 80s. And the newer ones beginning nearly at the year 2000, they are electronically controlled. So you have a server within this level crossing, and you have a possibility to get the data out of the systems. So what you see here, normally an electronic controlled level crossing system has an interface for a laptop, for the feed technician, who can go to the site and detect problems within the system itself. And we use this interface then to put a microcontroller at this location. You see a serial interface, so that's a year 2000 interface. But we get a lot of data into this microcomputer, and there's also an OPC UA server running on this one. And if the level crossing system has no direct contact to the interlocking system, it works, in this case, it works autonomous, then we use a 5G modem to transport this information from this small OPC UA server to our big diagnostic system. In other cases, we have a direct connection between the level crossing and the interlocking system itself. Then we have a wire here, and then we use an IP-based protocol over firewall with routers directly to the diagnostic point, which is located at the interlocking system itself. And if you do this, you have two advantages. One advantage is that the feed technician can do a remote view into this interlocking system, which can be somewhere right outside in the root area. And he gets the information, what spare part is needed, what could be the root cause of the defect. And on the other hand, we have a chance also to get some information for our customers directly from this level crossing, because maybe some organizations like the fire department, they want to know when will this level crossing be closed, yeah, because maybe they will use another way, it's shorter from the routing point of view. And also maybe in a longer future, Google Maps, etc., you is also interested for routing course. How long will it close? When will it close? So we try to bring this information also to other routing systems. which can be then adopted by routing systems like Google Maps or for our firewall departments. Okay, then next one. So what I showed you before was the old world, but now we start with a new one. Within Germany, there's a big project to exchange all the old interlocking technologies out of the network, because some of them are really 100 years old, mechanical interlocking systems. Then we have relay interlocking systems, and a lot of them are failed because they are so old that they don't have they don't can be supervised, and therefore we started in Stuttgart, Stuttgart 21 with a big project, and from there to the complete country, where we exchange all the interlocking systems. And if you look here into the graphic, you can see the interlocking system there itself. That's the technical side. Yeah? And from there, via IP, we have a interconnection to the systems outside, like the Excel counters, the point machines, or the light signals. And we have a second functionality. We don't only control them, but we also supervise them with the OPC UA protocol and bring this information into this technical side, and from there into operating side, where we can start the diagnostic of all these systems. And so not only the interlocking system and its components outside in the trackside area are supervised via OPC UA, but also some systems for the automatic train operation in the future, because we want to remote control the train, and that's one thing. And the other thing, we want also to supervise equipment on board of the trains, which use ETCS or ATO, automatic train operation, um, to enhance railway traffic in the future. Next slide. Okay, so if you look for our rollout, because we are still in the beginning phase, we are somewhere here below 10,000 elements, which are directly connected with our new digital interlocking systems. But in the next years, you see our rollout curve is a big infrastructure program within Germany, and mainly the corridors from north to south, or the big cities like Cologne or Netherlands and Brussels. This direction along the Rhine River, these are the first targets of our rollout of new infrastructure. And this, what you see here on the map, should be finished in 10 years, around 10 years. And then we have around 75,000 field elements, which must be supervised with this new technology. And the biggest advantage is, as Karl said, we try to bring this into the standardization. So all new systems, all our new interlocking system contracts, all our new contracts regarding level crossings, they all contain diagnostic interfaces with the OPC UA models, which are standardized mainly in the European programs like Europe Sail, or together with the industry in ULinks. And therefore, it's a big impact on the market. And what we can see, that also the countries around Germany, like our friends from Switzerland or from Austria, they also take this same models, and this gives a big impact on the industry to build up these models into their interlocking systems. And this is really a very good chance for the future. So thank you for your attention. And so that was a perspective of a user.
Thank you so much. I'm deeply impressed. That's what I've totally not expected. I was not aware of this, and I'm so thankful that I run into you, Karl, during the Hannover Messe. Amazing. Multiple things. What my personal impression is. Number one, by accident we hear from this project. Number two, you are using OPC UA in a much more extended way than we ever thought, for the spare part and looking and diagnosis and this is what a lot of people use in a lot of projects, yes. But also what I'm really proud on, you are planning for 10 more another years, and this is what I mentioned in my keynote this morning. You would not do this if you can't trust the technology, and OPC UA has proved that it is already 19 years stable without losing backward compatibility, and that makes it so robust for the industry. Again, thank you so much. Now I need a little bit advice here from Alexander, and you can even switch on also your camera, Alexander, because I don't know if these two experts are available later for the Q&A part or if we need them right now because they're online and we have some questions right now.
Sure, of course, we have received some questions, so we can run through them. First question goes to Karl, as much as I recall. That was part of your presentation yet, and that was, how do you do field element authentication during the configuration updates?
So we don't only have the information models as a standard. There is also an extensive standard being developed at Europe's rail on shared security services. And I think short answer, very short answer. So you have to go, if you want to participate as a building block that gets a configuration, then you need to go to the NAC. The NAC has to look at the EIM if this is a building block that is really part of the network. And if this is then being made sure, then you're getting a token, getting back to the building block, and then you know that this building block can take part in the process. And what is also important is that you have a token on the building block itself, that it is identified as itself, and if that is going to fail, then it is being put physically or however to the replacement part. And from this, you then put in all the certification processes. You have manufacturer-specific root certificates, and you also have these from the operator side, and they have to work together in a PKI infrastructure. So I think this is also part of the standardization. It's not directly what we need to do with the configuration working group and the diagnostics working group. We are just using these standards for our needs here.
Perfect. Okay, then let's move on to a question for Wolfgang. And the question is about the point motors, or more related to the actual number of point motors that you had. With so many components connected via OPC UA, do you know how much data is being processed in real time by your central client?
That's a difficult one. Right?
That's what I assume. That's always a little difficult. But well, let's pull out like one of the top.
But not all of them switch at the same time, and only during the switch over you get the samples. Yes, with the current. Though I think we have a lot of terabytes per year, and we store this data. And as you know, we need this also for the prediction, because we want to compare the old data against the new measured to find out if something changes, and therefore you need this history. So we need terabytes of data. Definitely.
And how regards with like with real time? Are you collecting those information? Like I assume real time in that context is not deterministic real time, like in microsecond ranges or something. But I guess that you're collecting them in near real time. So
It's
I don't know, tenths of milliseconds to have everything updated always, something like that.
yes, it's like that, because it's, as I said, the data loggers, which are connected to the sensors, if they receive the samples, they offer them directly on the OPC UA side, and so we see, and if there's a new data set, it's directly connected to the client, because it looks directly at if there's a change and then gets a new data set.
Perfect.
It's nearly
And now,
online.
yeah. Now we just learned about that those information models. So one of the questions here was whether this is actually publicly available. So did DB publish those information models, or are they closed
Yes.
ones?
No, as Karl said, we started to develop them with DB, and then we look for partners, and we look for other railways which are interested to use these models, and for the industry, for the big suppliers. And this is ULinks, that's an initiative of the railway operators together with the industry to standardize such models. And from there, we go to Europe's rail, because then we can fix the standard at the end of the day within the system pillar. And this is what Karl's explained. And everyone can get these models. And this is our interest, because the market share must be as big as possible, that all of these suppliers are forced to implement the diagnostic data. And also the railways, as German Bahn, as I said, they write this in their contracts that we require them, so that we get a push into the market.
That is very good, because that is what I've learned over the years, that as long as there are no end users really having that in their call for bidding, it's just a check mark that you easily check off, right? Do you have any idea about like a time schedule? So when will it be adopted by the European Railway?
I think, as I said, in Germany we use it. In Switzerland, they put this in their contract at the moment. They make an order. Also, the Austrian railways do this. The point machine models are used in the Benelux since 5 or 6 years. So I think there's a big push in the market, and also the industry, the big suppliers like Siemens, like Hitachi, and other ones, they ask for standardized models. So they look not for individual models from Germany or from France or something from there. They look for standardized models, because they want them implement them once and not for each individual. And that's the idea behind it. Yes.
Yeah, often suppliers have just the same problems as everybody else, right? Finding good, knowledgeable people is difficult. So you need to efficiently use the ones that you have. So having one standardized model is way easier than having 10.
But a big advantage, as Karl said, we have this hard part, this hardcore, this fixed core, but we have also the possibility to enhance the models, especially the equipment model, because the equipments can be different from the different suppliers, but then they have the same methods, the same kind of objects they have to use. So we are compatible on one hand, and there's also the possibility to enhance the model from the industry side. Yeah, that's the good news.
That's always there was something important with OPC in the information modeling right from the beginning, right? So you have your interoperability by defining the core as a standard, and then providing the flexibility to extend it as needed by the individual vendors. No, very good, perfect. So we received a few other questions as well, but I don't want to hold you off too long, and also not the other presentations. Maybe I can just pull out one last one real quick. And you already answered that in one of your slides, but there was a question about how long will this take, and is this already rolled out, or is this future music?
No, it's rolled out. We have rolled out our system. We have the first reference implementations also from the new digital model, like which will start in Stuttgart. You can see it. We use it.
Perfect. Perfect. Very good. So, Stefan, do you have some last comments to it?
Well, two comments. Number one, because I was at the SPS Italy last week, Peter, Lutz, and myself had 2 or 3 questions from companies where they are planning to use OPC UA inside the train. And they're using OPC UA safety for example, there are some security relevant mechanism, like the train cannot start if a door is open, or if during during driving the door opens, the train has to stop immediately, and something like that. And so they ask us about OPC UA modeling and safety mechanism, and we said, oh wow. But if I hear all this, it's amazing. You know, gentlemen, I think in 2000. Oh, when was it? When did we have the OPC Day Automotive, Alex?
18?
2016?
17? I don't know.
2019? I don't know, but a year before I was at Volkswagen, and Volkswagen wanted to know a little bit, wanted to learn about OPC UA, and I went to Wolfsburg. We had a 3-4 hour meeting with I don't know, 25 people in the room. And when I was leaving, I had 3 wishes. Number one, Volkswagen gets a member of the OPC Foundation. We should do an OPC Day Automotive. And I forgot what the 3rd wish is. So my wish here is, hey, German Bundesbahn, why not become a member of the OPC Foundation or write a success story? But maybe we should really do an European OPC Day railway infrastructure. That's amazing. I believe there are so many talks. And we would love to hear also, what are your wishes? What can we do for you, right? We try to listen. Gentlemen, thank you so much. Wolfgang, thank you for all the details and being on site here. Thank you so much. Karl,